Dr. Christophidis, you are a Cypriot living in London.
Yes, well, if I told you that when I was a child in Cyprus, I could see myself growing up and coming to London to live, I'd be lying to you. Having said that, I should point out that since I was a child, I used to like science, especially biology, and chemistry, of course. I went to study biology, and even when I was nearing the end of my studies at the University of Athens some 15 years ago, I could never picture myself as a university professor and researcher. It's not an easy job. It demands a lot of commitment and sacrifice. However, it pays you back. It pays you back in a big way. It's one of the few jobs, if you can call it a job, I'd usually say an everyday hobby rather, that gives you a sense of complete freedom and creativity on an everyday basis. There's a sense of uniqueness as well. And this is something I always stress to my students, that to become a good scientist, one must not set limits to one's thoughts and imagination. One should always push the envelope.
How did you end up at Imperial College?
When I finished my PhD at the University of Athens, well, I'd already been away from Cyprus for a number of years, and I had to take dramatic decisions. Even though I missed Cyprus, I was ready to return. I took the next step. I went to the molecular biology laboratory in Heidelberg in Germany for postdoctoral studies. There, I had the chance to work with a great professor from Greece, and, I would say this was very determining in my decision to remain in the subject. In this way, when in 2005 I had a proposal to come to Imperial College, I gladly accepted. Imperial is one of the best 5 research centers in the world. The work of my research team for the last few years, between Heidelberg and Imperial, deals mainly with contagious diseases transmitted mainly by insects, and particularly malaria. It may sound very distant and strange to us in Europe, but malaria is responsible for the deaths of 3 million people every year in the world. Malaria kills 3 children every minute. Or in other words, by the time we finish our chat today, 25 children will have died. One can see then that our inaction makes us accessories to this crime. Malaria is caused by a unicellular organism called Plasmodium, and its name is derived from the Italian for bad air, because in the old days it was thought to be airborne. This parasite infects our red corpuscles, and at first causes anemia, and then liver failure. At the same time, however, it obstructs the flow of blood to the brain, causing permanent damage to the brain and ultimately death. When inside the mosquito, the parasite decreases dramatically in numbers. We came to the conclusion that some mechanisms of the insect killed the parasite. The experiments we carry out, and this is what we want to establish, aim at discovering these mechanisms in order to be able to use them to eliminate the parasite in the mosquito. Recently, in collaboration with other research centers, we analyzed the genetic code of the mosquito, the carrier of the parasite. We found out that it consists of approximately 15,000 genes. Using robotic technology, we placed all these genes on microchips and observed how each gene is affected by the parasite. Well, we discovered that indeed some genes react to the presence of the parasite. By altering these genes, we managed to transform the mosquitoes from bad carriers of the parasite to good carriers, or vice versa. We could either increase the number of parasites or decrease it.
Have you or your team made any discovery about the future of malaria?
Well, when these results came out, there were articles in the press that we were near to the eradication of the disease. My reaction to that was that we're still years away from being certain about anything. At least 10, 15 years. Today, we're still in the process of studying the mechanisms with which these genes work, and we have extended our research from the lab to the real environment of the contagion of malaria, to observe what happens in Africa and how the disease is transmitted to children. Our studies are going well, but a lot of work still needs to be done. Along with the defensive mechanisms of the mosquito against the parasite, we're studying genes of the parasite which play an important role in the transmission through the insect. We've located a lot of genes, and in the future, these might help us or others in preparing a vaccine which will stop the contagion of the parasite to humans. But it's a very difficult situation. We have to deal with a disease which goes back in time to the beginning of human history.
Is a scientist of your caliber allowed to have time to himself other than his research?
Of course. Not only is he allowed to, it's imperative that he has it too. We would never be good scientists if we didn't have a good private life, that's for sure. Now, if you're asking me whether or not there's time to do other things, that's another story. One, however, must try to find it. And there is time if you try to.
What do you like to do in your spare time?
Well, London is a very nice city to live in. You can go to the cinema, theatre, museums. You can go shopping. Or you can just walk around London. There are lots of good restaurants. Well, we try to combine all these activities with my wife, who's also a scientist at Imperial College, and we try not to spend the whole day closed in the laboratory.